It's day 118, no, 113 of me practice my speaking skill, and I think that today will be the last day that I attempt to summarize my knowledge about a carburetor. If you guys don't know, or I mean, if you guys aren't really interested in technical stuff and in engineering, especially in an internal combustion engine, then yeah, you guys should definitely skip this video. Let's keep going. A carburetor is, simply said, a simplified version of a carburetor. No, a simplified explanation of a carburetor is a device, a part that atomize fuel and air together and put that into the chamber of the internal combustion engine. It's not that simple. Okay. So a carburetor serves as a device that mix air and fuel and put that into the engine for combustion. As for combustion inside the internal combustion engine is to generate force so that the piston move up and down, thus allowed all of the different kind of movement that we usually see in a motorcycle or automobile. I haven't searched about that. We will definitely do that in the future. So a carburetor tends to have an intake and an outtake. The part that letting the air, and that's it's usually looks a carburetor usually look like a part that have a long tube connecting from outside air to the intake port of the engine. Then there's gonna be a cap that will be a tunnel protruding outward in the middle of the tube, and there's a cap that we can there's something on top that's look kind of like a cap, and on the bottom there's a bowl, there's a chamber that is bigger than the cap on the top, and it serves as a place to store fuel. Without visualization, this would be of course it would be without visualization, of course it would be confusing as hell, whatever gets going on. So the main parts of a carburetor is the carburetor have two main parts. For the first one is the venturi, which is the long tube that I've mentioned, and the bowl. The bowl is the place where we store the fuel, or most of the case gasoline. A bit in more detail into the bowl, then the bowl have a float. So the floats are made of really light material that will float up when there's more gasoline or more fuel coming to the bowl. When the gasoline fill up to a certain amount, the bowl will float. The bowl will move up in its position, and there's a needle that's connected to the float movement, so it will block the path that supplies the gasoline. So this serves as a way for the boat to manage its own gasoline level. There's an overflowing tube on top of the level that was predetermined by the manufacturer that will ensure the gasoline will flow out in case there's some overflow, there's some mistakes or deterioration in the bowl. And there will be a layer of air on top, and there will be tube that equalize the air atmosphere from outside to the inner side of the bowl to basically equalize the atmosphere. Because without equalizing the atmosphere in the bowl of the carburetor, it wouldn't really work efficiently, or it would just malfunction at all. Malfunction. Yeah, added up malfunction. Then let's move on to the venturi. The venturi here is the main part of the carburetor. The venturi basically have a wide tunnel of air, then it's gonna squeeze down into a thin small tunnel, and that's gonna be wide again and get put into the ports of the engine, intake port of the engine. There's gonna be lots of hole and lots of different intricate detail in the venturi. But first, let's talk about the physics of the venturi. The main physics mechanism of the venturi is based on the conservation of energy and based on Bernoulli equation. So based on that, when the air is being sucked into the intake port of the engine right here, and we move in this way, and when it's from a huge port into a small port, huge tunnel to the small tunnel, the static pressure will decrease and the velocity of the air going through the small tunnel will increase. So this decrease in pressure will create a pressure imbalance between the small tunnel and the bowl at the bottom of the carburetor, and there will be a jet. Let's call it jet. There will be small hole that's connected between the small tunnel in the venturi and the bowl. So that's basically allow fuel that's at the normal atmosphere pressure flow from the bowl to the engine. Basically, the fuel gets sucked out because as atmosphere pressure basically push the fuel up, push the fuel upward, because the pressure in the small tunnel will be lower than the normal atmospheric pressure. That will push the gasoline upward. Of course, the reason why fuel was pushed upward instead of air was because there's a small tunnel that is connected between the bowl and the venturi, and it was at pretty much the bottom of the bowl, so there would be no air at that point in the gasoline. So let's move on to the main detail. There will be four main phases of the carburetor. The first phase is the cold starts phase. So this basically about starting an engine when it wasn't even spinning or doing any combustion for a while at all. So there will be hole in the choke plate, or there will be an enrichment path that also have its own venturi and fuel path to basically make the mixture richer, which means there's more fuel in the mixture. The percentage of fuel in the mixture is higher than the previous one. I also forgot to say that in the past there used to be a carburetor that have fixed venturi, means that the small tunnel, the venturi size will not change. But now with modern carburetor, we can change the size of the venturi either through the mechanical slide carburetor or CV constant velocity carburetor, which will change the size of the throttle based on the throttle that we did on the motorcycle. This can be done by having a choke plate on after the small tunnel to basically control the airflow. The venturi will be directly controlled through the throttle, and the venturi that was controlled, there was basically a path, that was basically a lead in the middle of the carburetor, and there will be a spring, there will be diaphragm here, there will be a lid here. It was just mainly work based on the difference in pressure, that the more we turn up the throttle, the more the spring will be compressed, and thus allow the venturi or the small tunnel to be larger to allow more air to come in. The carburetor require a richer mixture of fuel and gasoline and air when it was first started, but the later the later in the phase, when it's from 0% to 100% of its power, then the more powerful, the faster the engine spin, the less dense, the less gasoline, the less percentage of gasoline it requires in the mixture. So the leaner the air of the engine will need. So because of the change in requirements in the engine, that engineers have to make the carburetor with have to design the carburetor with so many intricate function, and thus allowed it to have 4 different kind of phases. It's already more than 10 minutes, but I just want to wrap it up because I don't want to drag this further. So after the no, I think I will make another video that will be shorter, in 5 to 7 minutes, so that I could practice my ability to summarize deep technical topic. After the quick start system, there will be idling phase where the speed will be kind of slow for the engine. There will be a idle passageway beside the main air passageway. There will be an idle jet, which is a path from the bowl up to the main passageway. So the air from the idle air passageway will draw fuel from the bowl up and mix with the main air from the main passageway into the engine, which make the mixture richer. There will be the middle phase, which will, in this case, rise the needle. Now, I don't think that I could mention all of the detail in the carburetor. I've already talked from simplified version into the detailed version, so this would be the last video that I talk about carburetor. Basically, I haven't mentioned that there were a taper needle that has a larger tip and thinner on the stem of it will block the hole in the main jet, which will slowly come up and allow the gasoline in the main jets or the needle jets to flow out. But this isn't really wasn't viable in the idle stage and the cold start stage. Only at the middle stage, then will the needle have lifted up enough to allow gasoline to come out of the needle jet. The needle jets and the main jets are connected vertically, so we come out of the needle jet and come into the engine. At this stage, the pressure and the speed of air would be so fast that the main intake from this stage is the main passageway. Of course, the way that gasoline also mixed with air and mixed with a mixture also come from the idling stage and the cold start phase of cold start phase, but it wouldn't be as much as the main passageway. There would be a minority. There would just be minor detail. And at the maximum phase, when the engine is at 100% of its speed, it will draw. The needle will lift it up so high, and eventually it will be so large that it would just be a slight difference in pressure. So tons of gasoline can just get pulled out from the bulb just based on the speed the suction force of the engine. So there wouldn't need a venturi at all, and the air would come in with a large amount of volume, and we suck the fuel in and get into the intake port of the engine, which will be so fast that the other ports, instead of the main jet and the needle jets, will be irrelevant. So I forgot to mention that the idle cold start stage, of course, at 0%. The idling stage is at 0 to 25%. Cold start can be between 0% to 12.5% before it's become relevant. The main stage, the needle stage, would go from 20% to, I don't know, like 80%, and the maximum power phase would go from like 75% to 100%. All of those things will mix together. They couldn't really be distinguished clearly from each other. And lastly, there will be another carburetor that will be coming up. They already existed that, but will be perfected and will be purpose like commoditized for the public in the future, and is vastly superior to the purely mechanical carburetor, which we have integrated electronic sensor and can basically uh, sense of the necessary stats in the carburetor, then go through calculation in the computer of the motorcycle automobiles, the IC or the ECU, or like or through the engine management system. Then it will calculate and give orders to the carburetor to tell it how much and how much food should it get and how large should it eventually be, all those kind of thing. That's it for a carburetor from introduction to detail. That was exhausting and time consuming as hell. But yeah, I did spot some of the flaws in my understanding of carburetor, but I've already summed up my understanding of it, not my knowledge of it. So I do think that my memory about carburetor is kind of solid right now and would be able to last for quite a while. That's it for day 113. See you guys in day 114. Oh, it's been long since I've made a long video. That's, yeah, a long video like this.